All right, so when we're talking about the power rule, sum difference rule, that sort of thing, this is just monomials, so we're just working on the power rule, right? 32 is a constant. We know that the derivative of a constant is always 0. Why is that? Because really this is x to the power of 0, right? So if you use the power rule here, it's 0 times 32, right? Because so we got 0. 0 times x to the negative 1, who cares? So it's 0. This one, 4 comes down, multiplies by whatever's in front. So in that case, just a 4. Write the x down, subtract 1 from 4. Done. Over here, power rule says that 12 comes down in front of the x. So the derivative is 12x to the 11. Constant, 0. Why is it a constant? Because there's no variable there. Straight line, right? Y equals negative 3.724. It's a straight horizontal line right here. Derivative is always 0 because the tangent line always has a slope of 0. This one here, is this tricky or not?
1.
1. That's right. Here's a 1. Bring it down. 1 minus 1 is 0, so that's x to the 0, so it's just 1. What about this one? Ooh, pi. Is that another variable?
Pi x.
Pi is a constant, right? So it's pi x to the what?
Pi negative 1.
To the pi minus 1. You guys get that? See that? Pi is a constant. So write it as pi, write it as pi. There you go. This one is 43 x to the 42. Good job. What's this one? What's that one?
0.
Yeah, don't be fooled. This is not a variable, that's a constant. So this is just 32, right? 2 to the 5, 32, 0. Don't say 5 times 2 to the 4. Don't say that. Okay? Good one. That's a tricky one. Good job. Okay, what about this one here? Does it work for negative numbers?
Yes.
You think so? Maybe? Well, you want to check your book? Yeah, look in your textbook. Hey, girls, quit singing. Look at your textbook. Does this work for negative numbers? Where is it? Look it up. Where's the power rule? If n is any real number, does that include negatives? Yeah. So I can do the same thing, right? So that's negative 2x to the power of what? Right, you subtract 1 from negative 2, you get negative 3. Good. What about this? Fractions. Work on fractions too? Are fractions real numbers? Of course. 3 over 2. X to the... What's 3 over 2? Minus 1.
1 over 2.
1 over 2. That's correct. What's another way to write this? What's another way to write to the power of 1 over 2? What's another way to write x to the power of 1/2? Oh, you guys got to know this. Square roots, yes. Yeah, x to the power of 1/2 square root x. So either of those would be okay right now. But you might see it in both ways. All right, number 2. So if you want to do number 2 real quick. Power rule. 12 times 8 is what?
96.
Thank you. 96. X to the power of what? 11. Good. What about this one? 9 times negative 3 is? Negative 27. X to the 8. Ooh, what's 4/3 times 3? Thank you. 4t to the power of?
1 over
1/3. Yep. That's good. What's negative 3/4 times 8? So this is what? Negative 6. Okay. 8 over 4 is 2. Negative 3 times 2. Negative 6. T to the power of, what's negative 3/4 minus 1? Well, 1 is 4 over 4, right? So what's that? Negative 7 over 4. So that's negative 6t to the power of negative 7 over 4. What's this all about? How do I rewrite this?
Would be
1 over x to the 4.
Negative 1.
So right now you guys don't know how to find derivatives of rationals. So this we need to write this as just a single monomial term, not a term in a denominator. So how do I rewrite this with x up top?
X to the power of negative 4.
Thank you, negative 4. See that? So you need to write it like that first, because you don't know enough rules to do it the other way yet. So this is what you want to do here. Same with all these. See this in the denominator? In the denominator, you need to move those up.
What about under?
Under square roots. Well, we'll see when we get there. Okay, I'll show you when we get there. So this is going to be negative 4x to the negative 5. Okay. So this one right here. Okay. So what do we do here? That's actually what? Well, that's actually, so this is going to be y squared. That's a y. Y squared over 9. Right? So that's the same as 1 over 9 y squared. Remember, this is a coefficient in front. That's the exponent. So our derivative then is 2 over 9 y. Okay? I did mean to skip F and G, yeah? F and G. You upset? Okay. So what about I? Actually, I think I assigned all of these ones to you, didn't I?
Yeah.
So I shouldn't really do any more of them.
I mean, you can
Should I?
keep going.
How about J? Let's do J. Yeah, you should do I. How about I do J? J is just like I, so I will do J. Okay, so what does this mean? Oh, this is actually can be rewritten as what? X squared, what? Thank you, to the power of 1/3, which actually is x to the 2 over 3. Now are we good? Now we are very good. Find the derivative, that's 2 over 3, x to the negative 1/3. Okay, did you get that? Questions about that? Cube root is the same as to the power of 1/3. Okay, exponent rules here. Now you can do, this is your answer. Does that help? Does that help for I? Okay, I'll do, what is this? Okay, L. I'll do L. One more. Last one. So this one right here, I want to get this out of the denominator up to the numerator, right? So that actually is 3 over what? How can I rewrite this? X to the 1 over 4. How do I get this out of the denominator and bring it up to the numerator? Yeah, 3x to the negative 1/4. So now I'm good to go. I can just do my power rule. So the derivative now is negative what? Negative 3 over 4. X to the power of what's negative 1/4 minus 1?
Negative 5 over 4.
Beautiful. Negative 5 over 4. There's your answer. Okay, that should be enough to get you through question number 2. So for number 3, when you guys get there, you basically, it says find the slope of the tangent line, that is the derivative, at the point whose x coordinate is given. So for A, you're looking for f prime of 1/3. That's what you're looking for. Find the derivative, plug x equals 1/3 in, that's your slope. So I'll do it over here. So this one is g prime of 32. So what's g prime over here for D? It's going to be, well, g of x is x to the power of 1/5. And so g prime of x is 1/5. X to the power of negative 4/5, I guess. And so you plug in the number that you're given, which is the handy part about doing this. You just plug in the number and you evaluate that and you get your derivative. You can break that down. Probably don't even need your calculator. Mm-hmm.
Yeah, that's not right. Oh, it's because it's 6 to the 3. Yeah, no, it's because it's 2 to the 3. 3 to 3 is 8 times.
The homework is just 3A.
Yeah.